So now the very basic question there was that why we don't call it constant, why we don't call it uniform. Now these terminologies can be alternatively used for this thing, but is at the start the things are different. We wait for a fraction of time for the current to stabilize. So that's why we don't call it constant. And also it magnitudes fluctuates because of the resistance of the wire, because of the temperature dependence of the flow of current. There are many factors there. So the thing is not ideally is constant, but it is considered is a steady state. Like if you look at the surface of the flow of water, then it is not exactly just like a sheet, but it is almost uniform, it is almost constant, and we call that situation is a steady state situation. So now we will go and write the law, the Biot law here. So the Biot law I have already written here that B is a function of R. Now what is this R? We will have to understand these terminologies a little bit. So understand this one. Look here, when we consider our frame, our coordinate system, then O is the origin, and from the origin, the source or the charge density or the charges, they are at certain distance which we denote by prime coordinate, r prime. So from the origin to the source is r prime, and then from the source to the observation point is this tilted r. So when we write rho of r, so this is basically rho of r prime because it is measured from origin. And then what is our observation point? We look at our observation point from the origin to the observation point, and that distance is equal to r, the same r which I have written primed here and here unprimed. So E will be a function of r, the r which is the distance from the origin. While when I write here, this here, when I write rho of r prime, and then this will be integrated on the volume element, and that will be d tau prime. Similarly, here I will write this is tilted r, and this one is r unit vector. Indeed, r unit vector direction, I will measure the things here, like here in this direction. And when I come to the Biot law, then in Biot law, I consider a loop of a wire, and it's a current carrying loop, and any part of this thing I consider is dl. Now is this current itself is a source, so that's why I will write is a dl prime, and I will integrate it all over its length. This is current I flowing here. Now from the source, the distance is to the observation point is tilted r is there. So it's a source as well. This is a source. So this is the tilted r being the distance from the source, and then I write dl mu naught I or 4 pi. Now mu naught is the permeability of free space. Mu naught, this is 4 pi 10 power minus 7, and its units will be from here, like magnetic field divided by, this will come out to be the Weber, or if I measure this in Tesla, in meter square will come with this. So the unit will be determined from here. So this is now a cross product here. mu naught the permeability of free space, is we were having the permittivity of free space there, and the same 4 pi is occurring here as well. We will have to note one thing, that electric field is inversely proportional to the permittivity and magnetic field is directly proportional to the permeability. The reason is that when electric field enters into a material, an opposing field starts, means an opposing field from the material start opposing this external magnetic field. That's why the more the permission, the more will be the opposition, and it is inversely proportional. It's a kind of resistance to the magnetic field. And here, if I consider this one, now is it only depends on the alignment, so it's a kind of permission, not resistance. That's why it is directly proportional here. Then here dm cross r, because the magnetic field, if I would have written it is I here is a vector quantity, and then cross r, and then dl will be there is a scalar element. So this is a cross product here. Cross product means that the result is coming out to be the circumferential, to be a kind of rotation. And as we were having the Coulomb's law is inverse square law, similarly this one is also in the Biot law is also in inverse square law. So if I write it in this term, like B is a function of R, then mu naught over 4 pi int integral, and I write I cross R unit vector, then I will be a vector, and this one is R square, and here I will write dl. As I told earlier, that if you consider this one is a vector, then you move that vector identity to the dl, because the current will be following dl, and mu naught I here, if I take I as constant, then the vector will come on dl on the length element cross r over r square. And this we call is inverse square law in case of magnetostatics. So here, let me discuss this unit here. This one from here, this will be, this is whether Weber or we use Tesla, and here this will come out to be meter square, and when I will come here, then it is ampere. So we can write this thing in its unit is Newton per ampere squared. Or 1 Tesla, we know 1 Tesla here, 1 Tesla. Tesla is also a unit of magnetic field, a very big unit of magnetic field, because usually our normal fields are in Gauss, and one Gauss is 10 to the power minus 4 Tesla. So Tesla is a very big unit of magnetic field. 1 Tesla is equal to 1 Newton per ampere meter. So in their dimensions, I can write this thing is this one. So I think it is sufficient for the introduction of Biot law. And next we will go and we will solve example 5.5. We start with the solution of of example 5.5, and the example 5.5 says that find the magnetic field a distance s from a long straight wire carrying a steady current I. So we are having this is a long straight wire, and current is steady current I is flowing in this wire, and we are to find the magnetic field 8 point P observation point, which is at a distance s from the wire. So to find this magnetic field, we know the equation, and the equation is the magnetic field at a distance s is equal to mu naught I over 4 pi in integral. This is EL prime cross R unit vector over R squared. Now in this equation, the method is that when you are solving something, then first write its formula. And here is its formula, here is its equation. So we have the equation, and now from the figure we will find different parameters here. So going through the different parameters here, the very first thing we are going to find out the dl cross r here. So our first job is to find out what is del cross r, and then we will write the rest of the things here in this equation, like we will go for 1 over r squared. Now look here, what is our dl? This is our dl prime, and this is its direction. And what is r? So this is r, which is in this direction. So we have dl cross r, dl in this direction and r in this direction. So we will turn this one, and it will point out of the magnetic field. So what about this thing? We know that this dl cross r, if I write that this thing is equal to, what about this? So you do multiply this thing. What is the angle between the dl, this is dl, and this is r? So the angle between them is alpha. So I can write this thing, that this will be equal to dl prime, a scalar, and then r unit vector means AB sine of the angle and the direction. So here this will be r unit vector will be 1, and it is equal to dl sine dl prime sine alpha. Now if I look here toward this one, in this figure, can I write this alpha in terms of theta? Because theta is something which is from that axis here. So definitely I can write this thing, because I know that sum of the angle of triangles is 180. So here, if I look here, then I know that theta plus beta and plus 90 here is equal to 180 here. And I know one thing more here, that angle alpha and this angle alpha and this angle is beta. So angle alpha and beta are also equal to 180, because they are completing the line here. So they are 180. From here I can write that beta is how much? That beta is 180 minus alpha. So this is 180 minus alpha, and now if I put the value of alpha, the beta there, then beta plus 180 minus alpha for beta and plus 90, and this is equal to 180. Now if I do see, then 180 and 180 are cutting each other on this side, and I can write that alpha is equal from here, alpha is equal to theta plus 90. So I come here and then I write what about sine alpha. So this is the sine of alpha is theta plus 90, and I will apply the formula, and the formula is sine alpha plus beta is equal to sine alpha cos beta plus cos, and then it will be minus cos alpha in sine beta. Now it will be plus. So sine alpha cos beta in sine beta cos alpha sine beta. So I can utilize that formula, and then I know that cos 90 will give me 0, and this will come out to be, and sine alpha will give me, sine 90 will give me 1. So we have this sine alpha equal to cos theta. And I can write that dl prime sine of alpha equals dl prime then cos of theta. They are equivalent. So, like sine alpha is equal to cos theta. So I have done this conversion here. And now if I do write about the L prime, this length is L prime and this is perpendicular. So if I write the base here, because here the angle, the sine theta starts from here, so it means this is the base and it reaches here, so this is the high part. So I have the L prime over S means the perpendicular or the base is called tangent theta. So from the figure I have tangent theta is equal to L over S, or I can write L prime equal S tangent theta. And then what value I need from here, I need the dl prime value from here. So if I do differentiate this thing with respect to theta, then this is the derivative of L prime, and then S is constant, and this will be secant square theta, and I can write this secant square theta, I can write is 1 over cos square theta. So 1 over cos square theta, and d theta will come with this. So I have converted the dl prime as well, and then I will write here with this. So this will come out to means the cos theta and cos theta will simplify, but